So we're going to take a look at a couple of examples. I'll go through these for you on the video, and then you could look at some other practice examples in the book if you wanted extra practice before you come into class. So example 1a says if the molar solubility of calcium fluoride at 35 degrees Celsius is 1.24 times 10 to the negative third moles per liter, what is the Ksp at this temperature? So I know it's asking me for Ksp, and they tell me that the molar solubility is 1.24 times 10 to the negative third moles per liter. So the first thing that I have to do is I have to write out the equation. So at equilibrium, calcium fluoride, which is a solid, is at equilibrium with Ca2 plus F minus, and those are aqueous. Now you have to make sure to balance it. So we have one Ca, but we have two fluorines. Okay, that's going to become important when we write our Ksp. So we have our equation now, and this says that the molar solubility of calcium fluoride. So if we think about this as the last row in our ICE table, at equilibrium, we have 0.00124 molar, right? Moles per liter. And so if we have 0.00124 molar, I have a 1-to-1 ratio of calcium fluoride to calcium, so that's 0.00124. And then I have twice as much fluoride ions. Okay, so that's at equilibrium, those are my concentrations. So what I'm going to do then to write my Ksp, I know that I ignore the solid. Okay, solid is not included because pure solids are never included in equilibrium expressions. So Ksp is going to be my concentration of calcium 2 plus times the concentration of F minus squared, okay, because I have two of them. So I will take 0.00124 times 0.00248 squared. Okay, so do 0.00248 squared times 0.00124, and you find that your Ksp is equal to 7.63 times 10 to the negative ninth. Okay, and Ksp, like any other equilibrium constant, is unitless. Okay, it's just a magnitude. And this tells us how soluble the calcium fluoride is in water. So this is a relatively small number. So this tells us that the calcium fluoride is probably not very soluble in pure water. So if this number would have been larger, we could have said that, oh, it's probably pretty soluble in water. But because it's smaller, it's going to be less soluble. So again, Ksp indicates how soluble the solid is in water. So for part B, it says that it is found that 1.1 times 10 to the negative second grams of strontium fluoride dissolves per 100 milliliters of aqueous solution at 25 degrees Celsius. Calculate the solubility product. So first, it wants me to calculate the solubility product. So what does that mean? So that means it wants us to calculate Ksp. Okay, solubility product constant. Now they gave us 1.1 times 10 to the negative second grams per 100 milliliters. Okay, in order to calculate Ksp, we need concentration. So what you have here, okay, I already did this for you on the slide. I took the concentration, to find concentration, I said we had 0.011 grams. I used the molar mass to get to moles. So this part right here is getting you from grams to moles. And then we have divided by liters. So 100 milliliters is 0.1 liter. That then got us our concentration. So strontium fluoride concentration is 0.00088 molar. So we have our equation. It's already balanced for you. Always double check, make sure it's balanced. So we have strontium fluoride at equilibrium with strontium 2 plus and 2 F minus ions. So again, if we think about this as the last row of our ICE table, we start with 0.00088 molar strontium fluoride. Okay, so that is the molar solubility of strontium fluoride. So that means if we look at this ratio, that 0.00088 molar strontium would form in the water, and 2 times that fluoride would appear in the water, again because of the coefficients. So to find Ksp, we only look at our aqueous ions. And don't forget about coefficients. So strontium 2 plus times F minus squared. So if we plug in those values, you get 2.7 times 10 to the negative 9th. And again, Ksp is unitless. So what we plugged in this 0.00088 here. We plugged in 2 times that here, and then we squared that. And then we found our Ksp. So again, this is a relatively small number. This tells us that strontium fluoride is not very soluble in water. So part C says the Ksp of barium iodate at 25 degrees Celsius is 6.0 times 10 to the negative 10. What is the molar solubility of barium iodate? So this one we're kind of going backwards. So it gives us the Ksp. So it tells us the Ksp. And then it wants to know what is the molar solubility. So it wants to know this. Okay, molar solubility is moles per liter. Now with Ksp, if they would not have given you this Ksp at 25 degrees Celsius, if you look in Appendix D, I believe, Appendix D of your book gives you all the values of Ksp that you would need. So if the problem doesn't give it to you, like if this just said, what is the molar solubility of barium iodate at 25 degrees Celsius, look in Appendix D of your book, and you'd find the Ksp value of barium iodate. So now if we take a look at this, again, think about it as the last row of our ICE table. We want to know what is molar solubility of barium iodate at equilibrium with the barium ion. So if this barium iodate is X, okay, if this right here is X, well, we also know that this is X, okay, because this is a 1-to-1 ratio. But if we notice, iodate is a 2-to-1, so that's going to be 2X. So at equilibrium, we have 2X of the iodate, we have X of the barium ions, and X of the barium iodate. So we also know that Ksp is equal to our barium ion concentration times our iodate ion concentration squared, okay, again because of our coefficients. So we know Ksp, okay, we know that Ksp is 6.0 times 10 to the negative 10, that times sign, sorry guys, equals X times 2X, let's get that in there we go, 2X squared. Okay, so don't forget, because this is 2X, that's what you plug into here. So we find that that equals 4X cubed. So don't forget algebra, okay, 4X, or 2X quantity squared is 4X squared. 4X squared times X is 4X cubed. Now, to solve for this, what we would have to do is divide both sides by 4, and then take the cubed root of that. And what you would find is that X equals 5.3 times 10 to the negative 4th molar. So again, whenever you solve for anything like this, take a second, think about what you just solved for. Okay, X is the barium iodate concentration. It's also the barium ion concentration, but if you wanted to solve for the iodate, you had to make sure to multiply it by 2. So it just so happens that this also equals the molar solubility of barium iodate. Okay, so this would be your answer. So it's molar solubility, so that's going to have a unit.